describing the shape of objects in engineering drawings, we have a way to deal with hidden features, and that is we use dashed lines. But sometimes there are objects that have so many hidden lines or dashed lines that it becomes very confusing and very difficult to understand. So we have a practice that has evolved called making section views. And section views allows us to open objects up and show interior details that would otherwise be hidden. In order to be able to understand section views, you have to have a fairly good three-dimensional visualization ability. Most of the people I find who have trouble with section views don't really have trouble with the idea, but they have trouble imagining what's really inside those parts. Also, there's a bunch of vocabulary to learn about section views, and there are a lot of conventional practices of how we project things other than exactly the way people see them. So all of these things are part of section views, and let's start out by taking a look at some common objects so that we can visualize a little more easily what we mean when we say make a full section or a half section or a revolved section. Well, one of the principles of learning that we teachers learn about when we're learning about learning is that learning takes place best from the known to the unknown. And so I'm going to try to use that technique in talking about section views, and I'm going to start by showing section views of something that's pretty well known. For example, you might not know that this little funny fish is my carving board, but I have a carving board here and I have an apple. I want to start out by creating a full section of the apple. So let me do that. Let's just take a knife here, and a full section cuts fully from one side of the object to the other. Now imagine here that I have this apple in front view and I want to make the top view as a full section view. Top view, I'll just open this up and you see that it's sliced all the way across. Full section view. Not to be confused with a half section view. Let me do another one to show you the half section view. In this case, I'm going to use my trusty Swiss Army knife and I'm going to make a front half section view. And a half section view, remember the full section view I cut fully across. The half section view I'm only going to cut halfway across and then I'll cut out. And here I have a top view, and if I take this part out, you see that I have a half front section view. Now you say, but you cut a quarter of the apple out. Don't be confused by that. I cut halfway through the object and then out, and it reveals what's inside the object. I usually use half section views for objects that are symmetrical about an axis. And by using a half section view, if someone wants to know what's inside the object, they look at the half sectioned half. And if they want to know what's on the outside of the object, they look at the unsectioned half of the half section view. Let's take a look at a revolved section. The cucumber provides a good example of a revolved section because typically we use revolved sections on things that are long and have a continuous shape inside. And the way a revolved section works is we pick a point for a cutting plane, and we just do this in our imagination, by the way. Actually, we never cut objects. We do it as an imaginary thing, and we draw the views as if they were cut. So we imagine for a revolved section cutting a little place and revolving that part right in place. You'll see later when we get to the formal views that we actually leave a little space or a little break in the view for the sectioned part. So here we have this long object and we want to show the interior, so we pretend to cut a slice and revolve it right in place, and in only one view we have incorporated a revolved section. Another type of section view that I want to illustrate is called a broken out section. And there are times when we have objects where a full section is not what we want to do, and a half section doesn't lend itself, or a revolved section doesn't lend itself, but we just want to break out a small chunk to reveal just the interior details in a certain area. Let me illustrate for you a broken out section. Now here you have a broken out section view. The thing I find about broken out sections is that they make it hard to talk. But actually there is such a thing. I'm not making this up. When we do a broken out section, we just want to reveal details in a certain limited part of the object. Well, that's probably enough silliness with a fruit, but you get an idea of the different kinds of sections. Now let's get a step closer to reality here. Suppose I have an object like this and I don't know what's inside of it. If I drew this object, I'd have all kinds of hidden lines. So what I might want to do is do a full section. Let me take this triangle and simulate my Ginzu carving knife here. And this simulates something called a cutting plane. And imagine slicing the object with this cutting plane. And once I've sliced this object, then what I'll do is I'll pretend to remove the part of the object that is between me and the cutting plane. Of course, the cutting plane is just imaginary. And what will be revealed will be, in this case, a full section view. Now, I've taken this object and I've painted part of it red. The part that I've painted red is the part that was actually contacted by the cutting plane itself. And once I've done that, actually I won't paint them red in an engineering drawing. In an engineering drawing, all this part that's contacted by the cutting plane will be shown by constructing something called cross-hatching lines, very evenly spaced thin lines. You'll see more of those before we're done. But what you have to realize is that we pass an imaginary cutting plane through the object. Part of the object is cut or touched by the cutting plane, and that part that's contacted by the cutting plane, we shade or color it with crosshatch lines. Once we open the object up, we can see things beyond the cutting plane. For example, even though there's a hole in this box, there's not a hole back here, and we would show that bottom or that back interior surface. See, it's flat on the back, but inside it comes down in here. So there's a little hole underneath. We wouldn't know that without cutting this open. So once again, to make the section view, we pass an imaginary cutting plane, and you can imagine the cutting plane with your triangle. We pass that cutting plane through, and we take away everything between you and the imaginary cutting plane and reveal the, in this case, full section of the object. Now, let me show you this object yet another way. I've created a little computer model of this, and I think you can see how this works in the computer model. Here on the computer display, I've created a model of that same block that I was showing you on the camera a minute ago. And this time, this computer display will allow me to animate and demonstrate this business of making a full section once again. First, let me throw in an imaginary cutting plane, and this is the cutting plane that I'm going to use to simulate the full section view. Now you see how this is cutting all the way across that block again. Now that I've used that cutting plane to pretend to slice that object, let me move the part between my view and the cutting plane away to reveal what's inside the object. Now again, you can see that I've colored in red the part of the object that was actually contacted by the imaginary, and remember these are imaginary cutting planes. And once we do that, you can see where the material is at the point where it was cut, and you can also see back into the object to see what's inside behind the cutting plane. It's kind of fun to put this back together, isn't it? But remember, all of these things are imaginary. We don't really cut the objects unless we want to do it as an example. Let me show you how I can create a more formal engineering drawing by cutting section views from a similar model. Here's another view of a solid model created in the CAD software of that object. In this particular case, I've created a front view with the dashed lines that show the interior. But now what I'm going to do is I'm going to cut a section view out of this, and I'm going to make a right side view that's actually a full section view. And these are the little lines that we use to represent on drawings the cutting plane. And then I can position that view over here on the side. So here you see the cutting plane represented by a line with a couple of arrows pointing in the direction we're going to look. And here you see a full right side section view. that you would get if you cut it vertically through the object. What if I wanted to see the top view as a full section view? And I'm going to cut right through the middle of the object, and I'm going to look down in this direction, and I'll put my cutting plane line about here, and I'll put the top section view right there. Let me adjust the display so you can see that a little bit better. And here you have a top section view. Here's a cutting plane line, and we imagine that everything behind the cutting plane, everything away from the arrows is removed, and we look in the direction of the arrows, and this is what we see. And I don't know if you remember that little box that I had, but it actually has a couple little tabs inside, and now when we look down, there they are as dashed lines. Now when we look down at the top full section view, we can see those little horizontal surfaces. When we look in from the right side, we can see that little horizontal shelf as well. Let me illustrate this section view business one more time with a real object. Here I have a little flange that I picked up at the hardware store the other day, and I painted it a nice gray color, and it's pretty hard to see what's inside this thing. It has interesting shape in there. So what I did was I took one and operated on it to make it like a full section. And here's the one that I operated on. Now let's pretend that I'm going to, again, take my triangle and simulate the cutting plane. Let's pretend that I'm going to cut right down through the middle of this, and then I'm going to take this part of the material away, and I'm going to look in that direction to get a section view in the front view. And you see the interior is now revealed, and once again I believe that you can see that I've colored in red the part of the material that was in contact with a cutting plane. And once I pretend to remove the part from the cutting plane back towards me, the interior is revealed. And I'll show the interior just as if I was looking at it, with these intersections of surfaces here will be shown as solid lines. So there's a full section view of this little flange. Let me show you, since it's symmetrical, how it might look if we did a half section view, because I happen to have cut another one. In the case of the half section view, remember, we cut part way through and then out. And if I had a front half section view, you could see that half of that view would be cut, and the other half we could see the outside. And on objects that are symmetrical view like this, half section views are very common because you can see both the exterior and the interior in the same view. Actually, I was having so much fun with this object, and I got tired of using my hacksaw and cutting away and painting, that I decided that now that I have some good computer modeling tools, I could actually, in the computer, create an animation of this part being sliced and removed. And oh, these things are great. These computers are wonderful toys to play with for this kind of thing. Well, I want to take advantage of my computer modeling here to illustrate the section view business a little more for you. And so I've created another model in the computer, and this time I've even had some fun. I've added some texture to it, and I can even have more fun, and I can go in here and I can revolve it. But what's hard to see in this model, unless I do a section view, is that there are actually some interior details in this thing. So let me go over here to a top view of the model, and then let me create a full front section view. And then I can position the full front section view. So although this is not a completed engineering drawing yet, we still need to finish the top view and make sure that there are dashed lines that show this little hidden groove, and we need to put center lines and of course all the dimensions. The point here is that to create a section view, we pass an imaginary cutting plane. In this case, since we're cutting through this in this particular way, the cutting plane looks like an edge or a single line in the top view. So we pass that imaginary cutting plane, and we pretend to take everything behind the cutting plane away and look in the direction of the arrows. And once we look, we see the interior. And again, whatever material is contacted by the cutting plane, we put these crosshatch lines, these evenly spaced angled lines, to show that part. And the material that's not contacted by the cutting plane, we show with normal object lines. Okay, here's your quiz question. What type of section view is this? Is this a half section view? Well, if you think this is a half section view because I cut it in half, you're wrong. I cut fully across. This is a full front section view. Let's look at another one. Now, here's another object that I've modeled to illustrate a different type of section view. Let me just show you the model first by going in here and rotating this around a little bit. You see there's some interior details there. There's something called a boss sticking up here. There's another one sticking up over here, and it has a counterbore hole. And it's pretty hard to see that if you look at a normal front view, even with all the dashed lines. So again, we might want to make a full section through here, but that causes a little bit of difficulty. Let me show you what I mean by that. Here's the top view of this object, and if I cut straight through, I can only get one of these holes or one of these features at a time. And it may be that I want to show the details of both these features. So in that case, I use something called an offset section. And again, I'm prompted to put my little cutting plane arrows, but this time I'm going to throw a little offset in the cutting plane before I quit. And now, by offsetting that cutting plane, I can cut through both sets of features here so that you can see these two holes and their little bosses, and in this case the counterbore, are nicely revealed. If you actually cut this object with a hacksaw, you'd get a vertical line right here. And you notice we didn't draw any vertical line because this cutting plane is just imaginary. And so we don't show any surfaces that are imaginary, because there are no surfaces. This is an imaginary cutting plane, but we've offset the cutting plane to pick up additional features. There are a lot of times when the offset section is a very powerful way to reveal interior details on an object. I'm sorry, but I just have too much fun with this solids modeling software, and I just have to do all these tricks. Here's another object, a flange-like object, and this has a pattern of 3 holes, and I'm going to show you a situation where we use something called an aligned section for objects such as this. Now, in this case, I'm going to place a top view in my drawing, and then I'm going to cut in a different way. So let me illustrate that. Here's a top view. Now this time I want to cut part way through. I want to show both of these holes without cutting straight through and without throwing an offset in. I'm going to do the aligned section. So I'll pick my little cutting tool and choose the aligned section, but turn off the offset because I could do an offset aligned section, too complicated for this part. So now I'm going to cut through the center of this object, and this time I'm going to put a couple of radial cutting plane lines in here. One of them through that hole and another one through that hole. And then I place the section view, and this will actually look like a regular front section view. However, you'll notice that the cutting plane has a bend in it, and we pretend that we've aligned that second hole, that we've swung it around till it's straight across, and we didn't project straight down to project a warp thing, but we've aligned the features before we place them in this section view. So here you see an example of an aligned section view, very commonly used when we have objects that are symmetrical about an axis of revolution. Remember when I was cutting the cucumber and we did the revolved section where we cut it and turned and placed the section right in place? Well, there's another similar process to that called a remove section, where we do the same kind of slice that I did with a cucumber, but instead of revolving and placing the section view right in the original location, or twisted from the original location, we do the same kind of cut, but we remove the section view. And I have an object here that shows you an example of when you might use a removed section. This object is circular on one end, is cylindrical for quite a length, but on the other end it kind of comes to a wedge-shaped point there. You see, it goes from round to rectangular during that section. There are other objects like, let's say, boat oars or airplane propellers that also have constantly changing shapes that are candidates for removed sections. I'll call up my cutting tool here. By the way, this is although that's a solid object as far as the computer software is concerned, it's displaying it as what we call a wireframe model, and there's some extra lines here that are just representing part of the geometry. And before we finished this drawing as an orthographic drawing, we would not include those wireframe geometry lines. But the solids modeling allows me to illustrate this cutting. This time I'm going to choose to remove the section. And the first cutting location is going to be here, and I'll make the arrows point to the left. And then I'll take this section, and instead of putting it right in place and revolving it in place or putting it off as a right side section view, I'm going to remove this and place it up here out of the way. And then I'm going to cut another one, because you see the shape there now. I think you can see that on the TV screen. Down on this end, remember the far end, it was rectangular, but in here it's starting to become elliptical. Let's see what it looks like if I cut a little farther along here. Maybe I'll cut right about there and drop another section here, only this time I'll put this one about here. And before I'm done, I'm going to do just one more. Cut it back in here and push section CC over there. And here you see a series of removed sections. And again, you would use remove sections when you have objects that are continuously changing in shape. And way down at the very end, this is very elliptical. A little farther along, at where I cut section BB, it's not quite elliptical. Farther along yet, where I cut section CC, it's completely circular. Remove sections are another type of section that allows us to adequately describe the shape of an object. Well, I want to go back and revisit briefly the revolve section, only this time I also want to show you a more formal engineering drawing version of it. You remember the revolve section that I simulated with a cucumber by slicing and revolving that slice right in place. You recall that if I would move that away, I could make a remove section. I could slice several of those, and we illustrated that with a CAD software. But let me show you how that would come out on an actual engineering drawing. Here's a drawing of an object that has this funny little I-beam connector between a couple of cylinders with holes in them. And it's pretty hard to tell exactly what the shape of that connector is unless we slice and look at it at another angle. So just like slicing the cucumber, we pretend to slice through here and revolve that right in place. And you see that I-beam shape then appears and is crosshatched. And you'll notice also that we draw these little break lines. And if you're doing this with manual drawing tools, you just freehand those break lines in to make space for the revolved section. And when you have objects similar to this, where you just want to show the cross section of part of the object, the revolved section is very handy. Now, along with the different types of sections, we have some conventions. And the conventions that are used with sections are used in many applications. One application that I want to show you is something called a sectioned assembly. An assembly drawing is not meant to show how people to manufacture parts, but is meant to show people how to assemble the parts. Why else would we call that an assembly drawing? In this case, there's an advantage in not simply doing an assembly drawing, but to do a sectioned assembly drawing. And when we do that, we have some conventions to be followed with a cross-hatching, or not cross-hatching in some cases. Here we have several objects assembled together. We have a shaft, a roller, a little washer, and a base. And if we had these parts in our hands so that we wanted to assemble them, we wouldn't need a multiple view drawing for that, because all we need to know is the order or the orientation of how they fit. Now, in the old days, you will find places where they had different cross-hatching patterns for different materials. In the old days when life was simple and there were only a few different materials to use, there was cast iron, there was brass, there was aluminum. But nowadays, life is no longer that simple. And we no longer try to show exactly what type of material things are by the kind of cross-hatching lines we put in. Instead, now we use pretty much always the 45-degree evenly spaced angled lines that in the old days referred to cast iron for almost everything, except when we get into a section assembly. What we want to do in a section assembly is we want to change the direction, change the spacing, and perhaps even change the pattern of the crosshatch lines for every different part in the assembly. But we keep, even though different areas of the same part, for example, this roller is partly to the left of the shaft, partly to the right of the shaft, it's all part of the roller. So even though it's disjointed, we keep the same cross-hatching pattern there. So we know that's all one thing. Also, when we have standard parts, such as shafts or screws or other things, we do not put cross-hatching lines in those standard parts. So in this case, the shaft, even though it's cut by the imaginary cutting plane, is not cross-hatched. It turns out that along with the section view business, you have a lot more to learn than just the 3D visualization necessary to imagine how these imaginary cutting planes cut through objects and how they look. There is a whole book full of conventional representations, and you not only have to learn the section view process physically, but you have to learn the vocabulary and the conventions that are used to demonstrate these different types of sections. Let me show you just a couple of more of these standard section view conventions. Here's an illustration where I have three different objects. I have a solid cylindrical rod, I have a pipe, a hollow cylinder, and I have just a square or rectangular block of stuff. Now frequently, if you're drawing something that has the same shape for a long time, like maybe you were drawing a rake handle, it would be a waste of paper to draw all of that thing across there. And so what we do is we put in what's called a conventional break. And there are different sectioning patterns we use to show these conventional breaks. For a solid cylinder, we use this trick. We use this little lazy S and a little, it's almost like an 8 that didn't get finished, and the upper part here is crosshatched on the other side of the break. The lower part's crosshatched. If we were dimensioning this, you'd see a little zigzag in the dimension line to show that this is not to scale. This thing is really continuing a long ways out here. Now, this is for the conventional break for a solid cylinder. For a hollow cylinder or a piece of pipe, it's very similar, except we show a little opening there to show that it's hollow, a part that's not crosshatched. And if you were drawing this, you would fake this in with your irregular curves or maybe an ellipse guide or something like that. If you're really good, you can even do it freehand. This is a break of a rectangular part, and this jaggy appearance shows that this is probably made out of wood. We don't see this as much now as we did in the old days. The convention then was to show wood with jaggy break lines, and if it was metal, to make these a lot smoother. But this is still one of the conventional breaks, and it indicates that this part really continues a long ways, and we didn't want to waste the paper or have to draw it very small to fit it all on the paper to get the entire length in. Now, one last thing before we're done. Let's talk about the lines we use to represent cutting plane lines and the different parts of the section view. This alphabet of lines shows the line style and thickness, relative thickness of the different lines for different purposes. And if you look at that, you'll see we have here section lining or crosshatch lines. Find out that they are always drawn very thin, and they're always drawn uniformly spaced. Also, you'll see a couple of different styles of lines used for cutting plane lines. If we have a long cut, we use what's sometimes called a phantom line. I have to do this with sound effects. It's the only way that makes sense. The lines are long lines and short dashes. And if we want to cut through a long part, then we'll use this long cutting plane. not to be confused with a center line, which just goes whoop, whoop, and is thin. Now, if we have a shorter cut to make, we might just use a series of long dashes. And in both cases, the short cutting plane and the long cutting plane, we put a little angle there and add the arrows. And these cutting plane lines are thick. So we have a lot to learn when we get beyond just doing simple shape description. We get into cutting planes, we get into section views, we get into a lot of conventional representations that go beyond just simple projection. And there's a lot more involved here than I have time to cover on this videotape. So when you get to this part in your lesson, you'll have to open up your textbook and very carefully study all of the different parts of the section and convention views chapter. Well, at this point, you've come a long way in your engineering drawing experience from the time when you first picked up a pencil and tried to decide which end of it to draw with. There's a lot to this business, and by now, with these 6 videotapes, we've just begun to scratch the surface. But it's an exciting business, and it's a very important business. I say it's important because not only has money been lost by people misrepresenting something or making a mistake on an engineering drawing, but lives have been lost. How accurately you make the dimensions, how accurately you make the views will determine how well parts can be manufactured. And we couldn't get along at all in modern society without manufacturing parts. And so I hope that you continue with your studies in engineering drawing. And as you get more and more experience, I hope you have as much fun and enjoyment as I have in creating these wonderful technical communication documents.